Good day, everyone. Here's our final project titled Solid Waste Collection Route Planner. This project addresses the challenges of inefficient solid waste collection in growing urban areas, where traditional methods lead to overflowing bins, delayed pickups, higher costs, and environmental issues like poor air quality and excess fuel use. A major problem is the lack of real-time data and route optimization, causing garbage trucks to follow outdated or inefficient paths. The project proposes a smart, user-friendly system to help municipal agencies create optimized waste collection using actual data on bin levels, trash volume, and truck capacity, improving efficiency and sustainability.
The main goal of this project is to develop a simple yet effective tool that supports efficient planning of waste collection in small communities. This project aims to simulate and visualize a basic solid waste collection process for small communities. It enables users to track bin locations, quantities, and estimated waste level at each site. By comparing the total waste with the truck's capacity, the system can estimate the number of trips required for each route. It also generates clear route summaries to support effective scheduling and planning. Additionally, the tool includes save load functionality, allowing users to manage multiple plans or reuse existing data efficiently.
Planner, a Python-based console application. This program helps simulate and manage garbage collection routes by calculating how much waste is generated on each trip and how many trips a truck needs to collect it. How the program works. Let me walk you through how it works. The system is organized into three main classes. Street. This class stores the name of the street, how many bins it has, and the average waste per bin. It includes a method that multiplies bin count by waste per bin to get the total waste for that street. Truck. This class just holds the truck's weight capacity, which is important for knowing how many trips it needs to make. Planner. This is the central class that manages the system. It stores all streets, holds the truck configuration, and does the heavy lifting like calculating total waste per street, determining the number of trips using sailing division, because a partial truckload still needs a full trip, giving warnings if a single trip won't be enough. Wrap up. The solid waste collection route planner is simple, but it shows how Python can solve real-world problems with clarity and structure.
The features of these projects are number 1, street and bin data entry. Users can input street names, number of bins, and estimated waste per bin to compute total waste per street. For number 2, truck capacity configuration. User can set the truck's maximum load capacity, which is used to calculate the numbers of collection trips needed. For number 3, automatic waste calculation. The system computes total street waste based on user input, minimizing manual calculation. For number 4, trip estimation uses ceiling division to determine the number of trips, ensuring even partial loads are accounted or realistically. Number 5, overload warning. It displays alert when WAS exceeds the truck capacity for a single trip, aiding in route and trip planning. For number 6, route summary generation provides an organized summary including street name, waste amount, record trips, and overload notification. For number 7, data saving and loading. It enables user to save any trip data using and supporting multiple use cases and persistent configuration. For number 8, user-friendly menu interface. A simple text-based on interface guides user through all operation, making accessible to non-technical use. These features Collective provide a reliable, automated tool for stimulating waste collection routes. The system enhances planning accuracy, reduces fuel waste, and improves overall efficiency solid waste management. The flow chart represents the process flow of a waste collection road planning application. The process begins with start application, which initiates the system. The first operational step is to set truck capacity, where the user defines the load limit of the waste collection truck. Following this, the user proceeds to add street bin data, inputting details such as location and bin sizes. Once the data is entered, the application moves to calculate total waste, where it determines the overall amount of waste that needs to be collected. With this information, the system proceeds to estimate truck trips, calculating how many trips the truck will need to make based on its capacity and the total waste volume. After this step, the system generates and displays route summary, offering the user a clear overview of the waste collection route and logistics. From here, the user has the option to either save the file, to preserve a current plan, or load from file to retrieve previously saved data. The application concludes with the option to exit or reset, allowing the user to either terminate the session or restart the planning process.